teach CBSE 10 Maths. Hey guys, this is Tina. I teach CBSE 8 Maths. Check out our videos on the playlist. Alright, now let's get into the video.
Today we are going to be learning Chapter 10, Circles, Exercise 10.2, 11th question. Alright, now let's read the question. Prove that the parallelogram circumscribing a circle is a rhombus. So we are supposed to prove that the parallelogram is circumscribing a circle which is a rhombus. Okay guys, so here now this is the circle upon that. So according to the question, the parallelogram circumscribing a circle. So there is a parallelogram which is circumscribing a circle means it is attached to the circle. Okay. So this is the parallelogram ABCD, and here now I am going to name this as R, and here it is S, and here it is Q, and here P. Okay. So now the question is, we are supposed to show it as rhombus. How to show it as a rhombus? So before that we are supposed to know the properties of parallelogram. So parallelogram has opposite sides. So I mean, of course, parallelogram has opposite sides in which those opposite sides are parallel. So for example, here we have DC, right? So here this AB is parallel to DC. Okay, so that is the meaning of opposite side. So opposite sides of a parallelogram are parallel. What is the meaning of rhombus? Rhombus means all sides are equal. Okay, all sides are equal. That is the meaning of rhombus. Okay, so now let's write the given values. So what is given, guys? So ABCD is a parallelogram. Parallelogram, and here now AB is equal to CD and AD is equal to BC. Okay, so here AD is equal to BC and AB is equal to DC. This is given, isn't it? So what are we supposed to prove? So to prove, what are we supposed to prove, guys? We are supposed to prove that AB is equal to BC and BC is equal to CD is equal to AD. I just told you we are supposed to show that this is a rhombus. How to show that? We are supposed to show all the sides is equal. Okay, so that's why AB is equal to BC. So BC is equal to CD and CD is equal to AD. That is what I wrote here. Okay, so to show something we need proof, right? So proof. So when you just look at this figure, no, we can actually apply theorem 10.2. So theorem, we can actually apply theorem 10.2, isn't it? How? What is the meaning of theorem 10.2? So the length of the tangents drawn from the external point, so this is the external point of a circle are equal. Okay, so that is the meaning of theorem 10.2. So you can see here, so these are the external points, those external points are equal. Okay, why? Because this is the tangent. So and this is what is theorem 10.2. So according to theorem 10.2, I can say AP is equal to AS, and then so AP is equal to AS, and then BP is equal to BQ, and then CR is equal to CQ, DR is equal to DS. Okay, so like this we can AP is equal to AS and BP is equal to BQ and CR is equal to CQ, DR is equal to DS. Okay, so this is because of theorem 10.2. Okay, so I'm going to take this as equation number 1 and this one as equation number 2 and this one is equation number 1 and this one is equation number 4. Okay, so now let us add all these equations. So adding equation number 1, 2, 3, 4, 5. Only 4 are there, right? Sorry. Okay, so we are supposed to add all the equation. So let's write AP plus BP plus CR plus CD is equal to AS plus BQ plus CQ plus DS. Okay, so we are supposed to add all the equations. Okay, all right. Okay, so now what we can do is so since you guys know, so here when you just check it out, 1 second, yeah, in the figure, no, where is the figure? Yeah, so in this figure we have AP right over here, isn't it? And we have BP right over here. So AP plus BP is AB, isn't it? So here no, I can actually write, so AP plus BP is AB, and then plus, instead of DR, no, I wrote CD here. Okay, this is actually DR. Okay, so here we are supposed to add everything, right? So here we have DR, so we are supposed to write DR here. Okay, so CR plus DR, so CR is right over here and DR is here, so CR plus DR is CD. Okay, is equal to AS plus BQ, so AS plus BQ, it is somewhere else, isn't it? So we have AS right over here and we want DS. Let us check it out. So we have AS right over here and we have DS here. So AS plus DS is AD, isn't it? So AD plus, and then BQ plus CQ. So BQ plus CQ. So BQ plus CQ, this one CQ, it is, so we are supposed to write the complete angle, isn't it? It is BC. Okay, so okay guys, so finally we got like this value. So since you guys know, in the starting I just told you AB is equal to CD, isn't it? So here I have AB plus CD. So in the place of CD I can actually write AB. Why? Because AB is equal to CD. So I can write AB plus AB. Why? Because I just told AB is equal to CD in the starting, because it is a parallelogram. Okay, and then is equal to AD plus BC. Okay, so here I can write instead of AD, no, I can write BC. Why? Because in the starting we showed that AD is equal to BC, right? So in the place of BC we can actually write AD. Okay, so here now we have AD, so I am going to write it as BC and then plus this BC as it is. So AB plus AB is 2AB and is equal to BC plus BC is 2BC. So cancel. So AB is equal to BC. Okay, so this is what you are supposed to prove, isn't it? I mean, so when you just look at it now, we have AB right over here and we have BC. So BC right over here. We got two angles, isn't it? And since you guys know, in the starting of the question here, here I just wrote we are supposed to prove that AB is equal to BC, right? So we are supposed to prove AB is equal to BC and BC is equal to CD and CD is equal to AD. But here we got AB is equal to BC. So what to do now? So no worries guys. So now what I am going to do is I am going to write this as it is. AB is equal to CD and AD is equal to BC. Why? Because it is given. Okay, and then now we just proved something, right? That is AB is equal to BC. Why? Because proved above. Okay, guys, so now I wrote it is a rhombus. So you guys might be wondering how is it possible. Now I just wrote the given value as well as what we just proved now. That one we got AB is equal to BC. We just proved it above, isn't it? Right over here we just proved it. I just wrote it as it is. Okay. So just because I got AB is equal to BC, then I can say AB is equal to BC and BC is equal to CD and CD is equal to AD. Okay, why did I write it like this? Just because I got a single value, that is AB is equal to BC, no, I can say it is a rhombus. Okay, so we want actually at least a single value to say it is a rhombus. Okay, so finally I showed it as rhombus, then this is going to be the answer.
Thank you guys for watching this video. Please like this video, share it to your friends and subscribe to our YouTube channel. If you have any doubt, comment me in the comment section. Catch you in the next video. Bye.